Section 7.2, Properties of Graphs of Quadratic Functions. So some things we need to know, and this is in your textbook. A parabola that is defined by the equation y equals ax squared plus bx plus c has the following characteristics. The parabola opens down if a is less than 0. So if it's negative 3x squared, it's going to open down. It's going to look like this second graph. Okay? The vertex of the parabola is the point with the greatest y value. So if you look at all of these y values here, it looks like the greatest y value is there. So when a is less than 0, when a is a negative number, it opens downwards, and that's a maximum value. If the parabola opens up, if a is greater than 1, so it's 3x squared, 1/4 x squared, 500x squared, the vertex is the point with the least, so this gives a minimum value. And it's symmetrical about a vertical line, the axis of symmetry through its vertex. So if we look here, this axis of symmetry would be an x equals, because it's vertical, and it goes through the vertex. So in this case, the vertex is 1, 2, 3, 4, 4, and 2. So I don't know why I wrote 0 there, sorry. So the axis of symmetry is x equals 4. The minimum value is 2, so we're looking at that y value. So let's just say I wasn't given a vertex. There was no clean point there. I couldn't tell. I could also figure out that axis of symmetry in the x-coordinate of my vertex by using symmetry. If these 2 points have the same y value, which they do, a y value of 4, they're directly across from each other, I could see that they were 4 points away from each other, so I know that that axis of symmetry is halfway in between. So that's another way I could do it, okay? A couple other things. For all quadratic functions, the domain, so that's all the x, domain is x, is the set of all real numbers. So what that means is if I extended any quadratic function, I could get a value for every single value of x. Every single value of x could exist. Okay? The range, or the y values, is a subset. So in this case, my y value is all the values bigger than that minimum value. So all y greater than or equal to 2. Okay? And in this guy, because I have a maximum, because it's parabola down, it's all y less than or equal to this point right here. Okay, so it's a subset. When a problem can be modeled by a quadratic function, the domain and range may need to be restricted. So if it's a real-world problem and I'm talking about cars, I can't have 4.5 cars. You know, it might just be only the integers or only the counting numbers. Or I might, and similarly, I can't have -1 car. Okay, so just be aware of that. There's lots of really good problems in your textbook that model similar questions that you're trying here. Oftentimes you can use technology. You can use Desmos graphing calculator. You can Google that. If you have an iPad or an iPod, there's a lot of apps you can get, or if you have a graphing calculator, would be very good. But make sure you also know how to use a table of values, okay? So if you're given a quadratic equation, if you're given y equals 3x squared, that you can make a table of values. You can say when x equals this, y equals that. That's another really good way to graph. So when x equals 0, I put 0 in, y equals 0. When x equals 1, well, 3 times 1 squared is 3. When x equals 2, well, 2 squared is 4. 3 times 4 is 12. When x equals -2, guess what happens? It's also 12. So make sure you're able, this is called a table of values. This is important to be able to graph a parabola. Okay, so you have some questions in this section to try.